Delay in music is a simple concept to understand. Play a sound, wait for some amount of time to elapse, then play a copy of that sound. It is a rudimentary audio effect, yet even in its most simple form, it has served musicians, audio engineers, and producers as an incredibly versatile tool for adding rhythm and depth to their work. In nature, delay can occur as a result of the speed of sound in air. At room temperature and standard air pressure, sound will travel at 343 meters per second. And if you're not at standard temperature, you can approximate the speed of sound by adding 331 to the temperature in Celsius times 0.6. So if you are standing some distance away from a sound source, there will be an inherent delay between when the source plays the sound and when you hear the sound. This is easy enough to measure as long as you have a couple of microphones, a large enough space to record in, a sound source, in this case, a snare drum, and a good DAW. What I've done is I've set up one of my microphones to be really close to my source, and then I've set up another microphone to be all the way across the room. I've measured the distance between these two microphones to be roughly 7.2 meters. As long as I'm recording with both microphones as I hit the snare drum, we should be able to see that there's a time difference between the two transients in the DAW. We can use that measured time difference and the distance between the two microphones to calculate the speed of sound in the air. As we can see by looking at the time difference between the two transients in the DAW, there's an inherent delay of 21 milliseconds. Dividing the distance between the two mics by the delay time gives us 343 meters per second. Comparing this to the approximation of the speed of sound based on the room's temperature, we see this is a reasonable measurement. While the time delay between my two mic setup was measurable, it was also extremely short. It wouldn't be practical to achieve longer delays with this method, but there are other reasons why you would want to mic your source from a distance. When sound propagates through space, it reflects off of the surfaces it encounters. A microphone in a space hears not only the direct sound from the source, but all of the reflections that bounced off the surfaces in the room as well. The combination of direct sound and its reflections is called reverb, and the spaces that are used for their distinct reverbs are known as echo chambers. Any space can act as an echo chamber as long as you can get a speaker and a microphone working within that space. Guitarist Dwayne Eddy even went so far as to repurpose a 2,000-gallon water tank so he could create his own unique reverb tone for recordings like Rebel Rouser and Peter Gunn. This effect is significant in its own right, but this video is about delay. So how does one create a discrete delay without all of the extra reflections? Well, if you wanted to keep your delay entirely mechanical, you could put your speaker at one end of a hose, your microphone at the other end, and then you could submerge the whole apparatus into a box that's filled with a sound-absorbing material. In 1971, Bill Putnam teamed up with Dwayne H. Cooper to do exactly that. The result was the Cooper Time Cube, a device that could mechanically delay an audio signal by 14, 16, or 30 milliseconds, depending on the length of the hose used. Alternatively, you could write an audio signal on a rotating metal disc submerged in a dielectric and create echo effects by adjusting the distance between recording and reading electrodes, like the Tel-Ray and Fender oil can delays of the 1960s. Both are viable options, but it turns out that the most popular form of producing delay makes use of a device that all analog recording studios already have. Tape delay exploits a quirk which all analog tape recorders have in order to create a time delay. Tape machines have a record head that records sound to magnetic tape. They also have a playback head that reads the data on that tape so it can be routed back out to a console or a monitoring system. These heads are physically separated by a short distance, so the recorded sound will play back a short amount of time later, depending on how fast the tape is moving from record head to playback head. This type of delay was particularly favored by the likes of Les Paul and Chet Atkins. Tape delay didn't remain just a quirk for very long. In 1953, Ray Butts invented his echosonic amplifier with built-in tape echo, allowing those who didn't have a spare tape machine lying around to use the effect. In the decades following, standalone tape delays would be invented and iterated upon. Notable units include the Maestro Echoplex, which introduced movable tape heads for varying delay times, and the Roland Space Echo, which included multiple playback heads. All of these methods for producing discrete, individual delays are still viable today, although they do come with their downsides. None of them take up as much space as an echo chamber, but they do still require bulky equipment that can wear out over time. Luckily, by the late 1960s, solid-state solution was around the corner.